Alright, Windows came to the container game late. Never mind though, Microsoft has done a cracking job getting them into Windows 10 and Server 2016. And I'm talking about native Windows containers here, the ones that run true blue Win32 apps. Now then, as part of the work to get them onto Windows, Microsoft had to put a bunch of new stuff into the kernel. Now at our kind of high level, we're talking about the two main building blocks that we've got in Linux, namespaces and control groups. The namespaces stuff lets Windows create additional isolated user spaces, containers if you will. And the control groups, or job objects, these let us group processes and slap limits on them. Looks familiar, right? Well, as that, they did a bunch of work on NTFS in the registry so that we can get image layering and all of that goodness like we do with AUFS and OverlayFS on Linux. Remember, a union file system or a union mount system with some copy on write is an integral part of a Docker container. Anyway, they also ported the Docker client and daemon to Windows. I mean, literally ported it, right? So we get a docker.exe process as the client and dockerd.exe as a Windows service, and that's the daemon. What all of this means is that we get the same API and the same user experience. Heck, we even get integration with Swarm and other stuff. Magic. Below this, though, we start to diverge from Linux. Remember, we said that instead of containerd and an OCI runtime, we get this compute services layer. But it does the same stuff. So as far as we're concerned, like as far as user experience goes, it's all the same. Same commands, same containers. Now, if you poke around inside of a Windows container, you're going to see a few differences there as well. We're talking about native Windows containers, remember, ones running Windows apps. Well, anyway, inside you're going to see a long list of system processes. And that's different, right? In Linux, we're used to seeing a single process per container. Well, you're not going to see that in Windows. And it's an artifact of how Windows works. Basically, over time, Windows has developed a bunch of interdependencies. So apps need certain system services and DLLs to be available, and in turn, some of those rely on others. And if they're not there, things break. And it's no different for containers. Every container needs these processes. Net, when we start a Windows container, it gets this process called SMSS. It's a bit like init if you know your Linux. It's got the job of making sure that all of these other required system services and the likes are all up. Once they are, then your app can start. Now again, I know it's a difference and I know it's easy to point fingers at and make fun of. But does it really impact the user experience? Nah, I don't think it does. Now then, Hyper-V containers. Okay, yes, it's true. We've actually got two different types of Windows container. Native Windows containers and Hyper-V containers. And both are for native Win32 apps, though you can do Linux inside of a Hyper-V container. But why two options? Well, native containers use namespaces for isolation. And down at the bottom, they all share the host's kernel. But sometimes that's not what you need. I mean, from a security perspective, maybe you don't think namespace isolation's all it's cracked up to be. Or maybe you've got an app that needs a slightly different kernel or a different patch set or whatever, right? Enter Hyper-V containers. When you spin up a Hyper-V container, Windows actually spins up a lightweight Hyper-V VM in the background. Now it is lightweight, right, so it's got less of a performance overhead than a full-blown VM. But inside, you still get a full-blown OS, so it's not using the host's kernel, a separate isolated kernel, and then you run your container on that. So, looking at the diagram, right, on the left side we've got the host OS at the bottom. Well, look, it's at the bottom for the lot really, but on the left side, the native containers are actually using it. They spin up directly on the host, leverage its kernel, and isolation is done with namespaces. On the right, we've got a VM. It's lightweight and all that jazz, remember, but inside it's still running a totally isolated kernel. And it can be Windows or Linux inside, right? Both work with Hyper-V isolation. Anyway, the container runs on that. And obviously, we can have a load of these on each host, but it's always one container per VM. That's kind of the point. Cool and all, but doesn't that make life a bit complicated? Well, not really. You just develop your containerized Windows app the same way that you always have. There's only one type of build. And then, whether or not you go with native containers or Hyper-V is just a deployment decision. If you want Hyper-V, you give the docker run command the ---- isolation equals Hyper-V switch, and to run it natively, you leave that switch off. And that's it. And I reckon that's the gist of Windows containers. A few low-level implementation differences, but user-wise, it's all the same. So if you're familiar with Docker on Linux, Docker on Windows is going to be a breeze. Now then, I know that this has been a ton of theory, and you might be like, oh my goodness, how am I supposed to remember all of that? Well, lucky for you, we've got a short, sharp recap coming up. Drinking from the fire hose, yeah? Love it. Well, let's quickly recap. We said that the stuff to build containers has been in the Linux kernel for ages. It was just hard to use, like too hard. Okay, Windows was a bit different. They had a couple of internal proof of concepts, but nothing got off the ground. So Windows is playing catch up, but the gap is closing and parity is not a million miles away. Anyway, the major kernel technologies that we're interested in are namespaces and control groups. They're pretty similar across Linux and Windows, and I reckon they're the two fundamental building blocks of containers, plus some sort of a union file system. Well, namespaces let us ring fence and isolate areas of an operating system, and this is basically the container. Then we sprinkle some control groups on top for capping resource usage. Add in a dose of some union file system or block device snapshotting, and we are staring at the model for a Docker container. This was all hard, remember though, and along came Docker, and everything got easy. Now, Docker iterated like crazy, and mistakes were made. Nothing worthy of death, right? Just a bit of a beating. Though to be fair, we're only talking about the kind of mistakes that every startup makes. I even feel harsh calling them mistakes. It's just part of making something great. Either way though, one of the issues was bloating of the daemon. It became way more than a simple reusable building block, and nobody was happy. Users weren't happy, Docker wasn't happy, and the ecosystem certainly wasn't. So Docker fixed it, and the community helped, of course. But these days the engine is way more of a modular beast. Not only is it in line with the tried and tested Unix philosophy that a few small simple components are better than one big one, but it means that a bunch of it is swappable and reusable. Okay, so the client talks to the daemon over a REST API. The daemon uses containerd to create and manage container lifecycles, and containerd uses runc to actually interface with the kernel and build containers. Now, there is some stuff left in the daemon that I'm not showing here, but the point I'm making is that the core bits are broken out into separate projects. Anyway, this effectively decouples running containers from the daemon, meaning that we can stop and restart and even upgrade the daemon without killing our containers. Gotta love that. And that's the Docker engine. Yeah, there are some low-level implementation differences between Windows and Linux, but the API and the user stuff is pretty much the same. And who knows, future versions of Windows might even ship with containerd and an OCI runtime. But maybe not. I honestly don't know. Either way though, I just think it's all a bit meh, no big deal. We're talking low-level stuff that doesn't impact us. Sticking with the Windows side of things though, there's native containers and Hyper-V. Natives run directly on the Windows host, so leverage its kernel and use namespace technologies for isolation. Hyper-V, though, spins up a lightweight VM for every new container. The idea being that VM isolation might be better or more secure than namespaces. Also, though, you get to run a different OS in the VM if you want, so different versions of Windows and even Linux. And yeah, I think that's us done. Now, thanks for sticking with me. I admit that I kinda love this stuff. But I'm hoping that you do too. In fact, reach out to me on Twitter with your thoughts. Is this kind of stuff good or bad? I'm really keen to know. Anyway, we're done, right? We're about to switch gears now and get hands-on with Docker images.